All right, so this is chapter 11, section 4. Adding and subtracting rational expressions. And thank goodness, our learning objective is to add and subtract rational expressions. Okay. So we are going to look at adding and subtracting rational expressions. So remember, rational expressions are fractions with variables in the denominator. So if you look at this, we have, it says, what is the sum? So we have 4 over 3y plus 7 over 3y. Fraction rules still apply. You have to have exactly the same denominator to add or subtract fractions. So I have a 3y and a 3y, so I can go ahead and do my addition here on the top. So if we're looking at 4 over 3y plus 7 over 3y, the denominator stays the same, and you just add the top. So really, I'm just going to add 4 plus 7 and get 11 over 3y. So the same rules apply when you have, in this scenario, we have an x minus 2. As long as I have the same thing in the denominator, I can add the numerators together. So here's 3x over x minus 2 plus x over x minus 2. I can add together the 3x plus x, and the denominator stays the same. So I get 4x, so 3x plus 1x is 4x's, and it's over x minus 2. This is the simplest form that you guys will see. So now let's do a problem together. Because what is the sum of 2a over 3a minus 4 plus 3a over 3a minus 4? So I have the same denominators. I can go ahead. So I want you guys to actually write this one down. So write this down. The second step is to write it, since when you identify that you have the same denominator, you can write the numerator added over just one denominator. Two A's plus 3A's is 5A's. And I get 5A over 3A minus 4. We're going to do the same thing with the subtraction, except everything on the right-hand side of the subtraction sign is going to get subtracted. So let's look at this scenario. Don't write it down yet. This is just for your viewing pleasure. We're identifying that we have the same denominator, 3x squared minus x minus 2, 3x squared minus x minus 2. Good to go. So now I can apply the same rules. So I have 7x plus 5 minus parentheses 4x plus 3. This minus sign is going to apply to the 4x and to the plus 3. So I got 7x plus 5 minus 4x minus 3 all over the same denominator. And now I'm going to simplify the numerator. 7x minus 4x will give us 3x, and 5 minus 3 will give us 2. The very last step is to factor the denominator if it's factorable. And in this case, because remember we've been talking about with these problems, you want to look for clues as to how things are going to factor. So because I'm left with a 3x plus 2, I want to look for the denominator to factor out a 3x plus 2. If you are patient enough and careful enough, the problem will tell you where it wants you to go. All right, so let's try this on our own. So I definitely want you to write these problems down. We'll do A together and C together. So A says 2 over z plus 3 minus 7 over z plus 3. Same denominators, we can move forward. Two minus 7 over z plus 3, we are going to subtract and get negative 5 over z plus 3. I know, easy peasy, and I'm just going by. Here, wait. So let's do the same thing with C. Okay, here we go. All right, let's solve this thing. So we've identified we have the same denominator, so we can write that, q squared minus 4. And then the numerator is going to be 7q minus 3 minus parentheses 6q minus 5. So let's distribute out this negative to each of these items. So this is equal to 7q minus 3, say, minus 6q plus 5 over q squared minus 4. We're going to simplify that out. 7q minus 6q is 1q. And negative 3 plus 5 is plus 2. Over q squared minus 4. Now we have to factor this denominator. This is a difference of squares. And if you didn't remember that it's a difference of squares, you can also say which two numbers multiply to give you negative 4 and add to give you 0. Plus 2 and minus 2. So once we do that, we know q plus 2 divided by q plus 2 gives us 1, and we have 1 over q minus 2. Is our answer. All right, so the last couple were, I call them Disneyland problems because everything is just magical and easy to do. Yeah. But what happens when you leave the park and have different denominators? No. So if you're in this scenario where I have 6x in this denominator and 2x squared in the other, the first thing you have to do is find the least common denominator. So here's a process that they use. Is there other processes? Yes. And can you use one if it works for you? Yes, but if you have no idea, then I would go with this one. So if you break 6x up into its components, it's 2 times 3 times x. If you break up 2x squared into its components, it's 2 times x times x. And then you write down the ones that are common, you only write down once. So each of them have a 2, so the 2 comes down. 6 has a 3, so it comes down. Each of them have an x, so it comes down, and then 2x squared has 1 extra x. So the least common denominator is 6x squared. Then you multiply each item by what it's missing. So I want 6x squared. If I look at x squared, I got to multiply it by an x because it was missing this little x guy. So I multiply the top and the bottom by the x. If you look at the 2x squared, he is missing this 3. So I have to go give him the 3 over 3. Once you have the common denominator, boop, 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 you simplify each of the tops and then put it over one denominator and add them. And this one doesn't simplify, so we are good to go. Okay, so let's give it a try. What is the sum of 3 over 7y to the 4th and 2 over 3y squared? So we are going to break these down. Thankfully, both 7 and 3 are prime. So 7y to the 4th is 7 times 4y's. 3y squared. Let's do it. Let's do it smarter. Smarter, not harder. And then 3y squared is. So altogether, I need a 7 and a 3 and a y and a y and a y and a y. So my least common denominator is 21y to the 4th.
I would love to ask that question.
All right, so we know our common denominator is 21y squared. We know we're going to give this guy a 3, and we're going to give this guy a 7, and we're going to give this guy a couple of y's. So I'm going to give, this one gets the 3. And then this guy gets the 7y squared. Need a little bit more room here. So then we simplify these down. This is 9 over 21y to the 4th plus 14y squared over 21y to the 4th. Now we can write it as 9 plus 14y squared over 21y to the 4th. Boom. Donors. All right, so we're going to do some more subtracting. We did adding in the last one. Now we're going to do subtracting. So we look at our denominators here. 3 over d minus 1 minus 2 over d plus 2. There is nothing common about these denominators. So the least common denominator between d minus 1 and d plus 2 is just the two items multiplied together, d minus 1, d plus 2. And by the way, if you are completely brain stuck on how to find a common denominator, just multiply the two denominators together. That's always, it's not the least common denominator sometimes if you do it that way, but it'll get you to the next step, for sure. Okay, so I'm going to give the first item a d plus 2. So it goes d plus 2 on the top and d plus 2 on the bottom. Then I'm going to give the second item a d minus 1. 1 on the top, 1 on the bottom. Then we simplify by distributing. So this is 3d plus 6, and this is 2d minus 2. Then now we can do the same process we did before. So we go minus, put it over one denominator, and And we go 3D minus 2D is 1D. And 6 minus negative 2, oh, that's 6 plus 2, which is 8. And we can't cancel any of these guys out, so we are just left with D plus 8 over D minus 1 times D minus 2. All right, so let's do that with this problem here. So go ahead and write this in your notes. C over 3C minus 1 minus 4 over C minus 2. C over 3C minus 1 minus 4 over C minus 2. So the first guy, he's going to get a C minus 2 to the top and bottom. Because if we're going to do math manipulation, we got to keep it squared. Keep it legit. The next one is going to get a 3C minus 1. Then we distribute C times C, C squared. C times negative 2 is negative 2C. And then minus parentheses. 4 times 3C is 12C. Minus 4. A little bit more here. Make sure that you, when you're distributing, go ahead and put it in parentheses. That way the negative stays where it needs to be. So I'm going to distribute out this negative, minus 12C. Negative and a negative gives us positive. All right, C squared minus 14C plus 4. And I'm just doing a double check. Are there two numbers that multiply to give us 4 and add to give us negative 14? No. Just to make sure we can't factor this numerator here. And that's our answer. All right, so let's talk about the gas mileage problem. A certain truck gets 25% better gas mileage when it holds no cargo than when it's fully loaded. Let M be the number of miles per gallon of gasoline the truck gets when it's fully loaded. The truck drops off a full load and returns empty. What is an expression for the number of gallons of gasoline the truck uses? So our gas mileage is M, and for when we're fully loaded. And then our gas mileage for when we're empty is 1.25 M. And where does the 0.25 come from? So 25% is 0.25. So you're not only going to get your gas mileage, but then you're going to increase it by 0.25 because it's 25% better. Step 1. Write expressions for the amount of gasoline used on the outward trip and on the return trip. The outward trip, gasoline used is the distance you traveled divided by the miles per gallon. So the outward trip, we're fully loaded. We go 80 miles. We divide it by M miles per gallon because that's our gas mileage. Our return trip, we have the distance traveled divided by miles per gallon. We're still going 80 miles back, but our gas mileage improves to 1.25. We add the expressions to find the total amount of gasoline the truck uses. So we have 80 over M plus 80 over 125 M. So we want to find a common denominator. So I have m, both of them have m, but this first one is missing a 1.25. So we multiply the top and the bottom by 1.25. When we do that, we get 100 over 1.25 plus 80 over 1.25. Add the tops together, and we get 80. We get 180 over 1.25m. And then we get, our total answer is 144, because 180 divided by 1.25 is 144 over m. So whatever our gas mileage is, 144 divided by our gas mileage will be the amount of gas we use. All right, so let's see how that's going to apply to this problem here. So a bicyclist rides 5 miles out, then rides back. The speed returning is reduced 20% because it's raining. That's terrible. Let R be his speed in miles per hour riding out. What is an expression that represents his total time in hours riding out and back? So let's look at A together. So we know that distance equals rate times time, and if you don't, you do now. So his speed returning, so we'll let R equal his speed, and then we'll let R times 1 minus 0.20, because he is reducing his speed by 20%. What is 100 minus 20? 80. And so what is 1 minus 0.2? It's 0.8, yeah. So his speed returning is R times 0.8. So we want an expression that represents his total time. So we are going to have time there plus time back. D equals RT. I want time. So if I want just time, time is equal to distance divided by rate. So it's how far you've gone divided by how fast you were going. So our time there is, what's the distance that we traveled? 5 miles. So we traveled 5 miles there, and we went R is our speed. And then time back, how far is it to get back? It's 5. Same distance. You get out there, you got to get back that same distance. And then we got 0.8 R. So we want to combine these together. So we know we have to get a common denominator. This guy has a 0.8 R, this guy just has an R. So we need to multiply by 0.8. So 5 times 0.8, what's 5 times 8? 40. So I'm going to move the decimal place over 1. So 5 times 0.8 is 4. So now I have a common denominator. I can add the numerators together. And I'm not sure if this is going to be. Let's test this to see if 45 over 4R is equal to 9 over 0.8R. So the reasoning is, In problem 5, suppose M represents the number of miles per gallon of gasoline the truck gets when it holds no cargo. What expression represents the number of miles per gallon, you guys don't have to write this down, of gasoline the truck gets when fully loaded? Explain. So the answer to that is 4m over 5 is the expression that represents the number of miles per gallon of gasoline when the truck is fully loaded, because N is the miles per gallon, and M equals 1.25. Therefore, N is equal to M over 1.25, or they've written that as 4m over 5.